f of x comma y is equal to 2 minus x minus y, which is 0 less than or equal to x less than or equal to y, and 0 less than or equal to y less than or equal to y. Otherwise, we are going to denote the value as 0. So we have to find the marginal probability function for both x and y as well as the conditional probability function for x and y. So first we are going to find the marginal probability density function. So first we are going to find the density function for x. So this is the formula for the marginal probability density function, that is f of x is equal to integral f of x comma y dy. So here the f of x comma y value which is given in the question, that is 2 minus x minus y. I am going to substitute the value, that is the integral of the given limit is 0 to 1. So the integral of 0 to 1 2 minus x minus y dy. So now we are going to integrate this term. So first I am going to split the integral for the all the terms. So while splitting, the value becomes the integral of 0 to 1 2 dy minus of integral of 0 to 1 x dy minus integral 0 to 1 y dy. Now we are going to integrate these terms. While integrating 2 dy, I get an answer as 2y. And the same while integrating this value x and dy, I get an answer as xy. As well as the last term y dy, which means while integrating this term, I get an answer as y square divided by 2. So that is the term which is written in the next step. Now we are going to substitute the limit in the integral finite values. So while substituting, first we are going to substitute the upper limit value. Here the upper limit value will be at 1. So the formula for the integral will be at the upper limit minus the lower limit. So while substituting in the y term, which becomes 2 into 1 minus 0. That is the 1 is the upper limit and 0 is the lower limit. That will becomes at 1 minus 0. And the next term, the term will be at 2xy. X is a common term and we are going to substitute the integral for the y term. Here also we are going to substitute the first upper limit, that is the 1 minus 0. And the same term we are going to substitute the y value, that will become at 1 minus 2 into 0. This is the term. So while simplifying this term, I get an answer, that is the marginal probability function of x, that is f of x is equal to 2 minus x minus 1 by 2. So this is the value for the marginal density function for the x. So next we are going to calculate the marginal density function for y. So the formula for the marginal density function of y is f of y is equal to integral of f of x comma y dy. Here also we are going to substitute the term f of x comma y which is given in the question, that is integral of 0 to 1 2 minus x minus y into dx. So in this step we are going to differentiate the same function with respect to x. While integrating, I get an answer. So first we are going to split all those terms. So that is integral of 0 to 1 2 dx minus of integral 0 to 1 x dx minus of integral 0 to 1 y dx. So now we are going to integrate the terms. While integrating, I get an answer as 2 is common. We are going to integrate this dx around. While integrating, I get an answer as x around. Then here x dx, while integrating, I get an answer as x square by 2. And in the last step here y is the common, we are going to integrate the dx around. While integrating dx, I get an answer as x. So now we are going to substitute the upper limit as well as the lower limit. So here the formula for substituting limit will be upper limit minus the lower limit. So 2 is as it is, we are going to write while substituting in the x instead of upper limit 1 minus 0. So minus of here x square by 2 also we are going to substitute the value, that is 1 by 2 minus of 0. Here also y is common term and we are going to substitute the limit for x around. So y into 1 minus 0. So this is the substituting value. While simplifying, I get an answer as, that is the marginal probability density function of y is 2 minus 1 by 2 minus 1. So this is the marginal probability density function for y. So next we are going to calculate the conditional probability density function. So the formula for the conditional probability density function is f of x by y is equal to f of x comma y divided by f of y. So we are going to substitute the all those value. The f of x comma y which is given in the question, that is the value 2 minus x minus y, and the f of y is nothing but that is the marginal density function of y. Just now we found what is the value for f of y is 2 minus 1 by 2 minus y. So substituting both the terms, next we are going to simplify. First I am simplifying the denominator. While simplifying, I am going to taking the LCM for this. While taking LCM, I get an answer as 4 minus 1 minus 2 by y. Again we are going to simplify, I get an answer, that is the conditional probability density function will of x will be 2 into 2 minus x minus y divided by 3 minus 2y. So this is the conditional probability density function of x given y. So next we are going to calculate the conditional probability density function of y given x. So the formula for the conditional probability function of y given x is f of y comma x is equal to f of x comma y divided by f of x. So here also the term f of x comma y which is given in the question, that is 2 minus x minus y. So we are going to denominate that they are given as fx. So fx means that is the marginal density function for x. So that also we just now we found the marginal density function of x, that is the 2 minus x minus 1 by 2 2. So we are going to substitute this value. So while substituting both the value, next we are going to simplify the terms. While simplifying, first I am going to simplify the denominator case. So while simplifying the denominator, I get the answer as 4 minus 2x minus 1 by 2. Again we are going to simplify all those terms. So the value will be 2 into 2 minus x minus 1 divided by 3 minus 2x. So this is the value for the conditional probability function of y given x. So in this problem we found the marginal density function as well as the conditional probability density. First we define the marginal density function of x. The formula for the marginal density function is f of x is equal to integral of f of x comma y dy. If it is in the y case, then the marginal density function formula will be f of y is equal to integral of f of x comma y dy. In the same case, we are going to find the conditional probability function also. The formula is given, we substituting all those cases and we found the value that is the conditional probability of x given by as well as the y given x. Thank you.
Today we are going to show you how I made this beautiful thank you slide in Microsoft PowerPoint. So if you want to be an expert, watch the video till